Hi guys, I hope you are all doing well. Let's see today's question. So today's question is combining of the concepts of arithmetic as well as geometric progression. We have discussed this already in the previous videos as well, that arithmetic progression is a sequence or a progression wherein the difference between the consecutive terms is a constant value, and geometric progression has ratio between the consecutive terms as a constant value, right? So let's first understand the question. We'll understand the question first. It is saying that let bi is greater than 1 for I equals to 1 to 101, right? So if I see this, means it's trying to tell me that there are 101 terms such as b1, b2, b3 and so on till b101. Further, it tells us, suppose log b1 then log b2 having base e, log b3 having base e till the 101st term of b, so log b 101. He's telling me all of this are an arithmetic progression and the common difference between all of these terms is log 2, right? So first, if I analyze this terms of arithmetic progression, we already know when terms are in arithmetic progression, what happens? Difference between the consecutive terms is a constant value. So if I take the difference between the consecutive terms, it becomes log of b2 to the base e minus log b1 to the base e is my difference d, right? And if I see log a minus log b gives me log of a by b, log of b2 by b1 to the base e, and the difference here is log 2. Now here also if I see, I can tell that if log a is equal to log b, a is equal to b, so I can equate this with this. That gives me b2 by b1 is 2. Simultaneously I can also get b3 by b2 is again 2, b4 by b3 is again 2. So what I understand from this expressions is the ratio of all the consecutive terms. If I'm taking 2 at a time, it is a value that is 2, and that is nothing but the common ratio or a constant ratio. So if I know that the logs of those b terms are in arithmetic progression, I understand one idea, that all the terms from b1 to b101, this 101 terms are in geometric progression and the constant ratio is, right? So this is the first idea which is given to us in the question. Let's go ahead. The second part of the same question says, suppose a1, a2, a3 till a101, they are also in arithmetic progression, and let's say they have any difference or any common difference d. So now I know when they are in arithmetic progression, the difference between the consecutive terms would be again a constant value, and that's equal to d. That we do not know what is the common difference here, that is not given to us. So we have two sequences given to us now in the entire question. The first sequence is your arithmetic progression having a common difference of d, and we also found out the other sequence of b terms was in a geometric progression and the common ratio here is 2, right? Now let's understand it further. It tells us that the first terms in both the cases is equal. Okay, so these two are equal to each other. Also, it is telling us the 51st term in both the cases is equal to each other. So that is also given to us. Let's see how we'll use these ideas. So first term, if they are equal to each other, let's take it as any other value. Let's say c, right? So a1 and b1 we are equating it with the c, a new variable. Further, it tells us T is sum of all the terms b1, b2, b3 till 51st term, and S is sum of all the terms of A from 1st to 51st. So sum of 51 terms of B is T and sum of 51 terms of A is S, right? Now we need to find whether S is greater than T or not. Let's understand if S is greater than T or S is lesser than T. So first thing what I will do is I'll use these ideas. We know for a geometric progression, when R is greater than 1, sum of all the terms becomes A, R raised to n minus 1 upon R minus 1. And for arithmetic progression, when I have sum of terms, that is number of terms divided by 2, 2 times the first term and n minus 1 times the difference. So if I apply both of these ideas, so first term, here we know the common ratio is 2. Here we do not know, it is some common difference d, right? So if I apply those two ideas here, sum of all the terms we know it is t. So t is equal to a raised to r in the geometric progression was 2. This is for first 51 terms, so 2 raised to 51 minus 1 upon r, that is 2 again. So that gives me a 2 raised to 51 minus 1 and upon 1, which is 1 only, right? So I get t is a into product of 2 raised to 51 minus 1. Now if I use the sum of terms of arithmetic progression, sum of all the terms of arithmetic progression is known, that is S. That is equal to n by 2. So 51 terms we are adding, so 51 by 2. 2 times A. A is, we are keeping it as A only because both of them have same first terms. N minus 1. So n is 51. 51 minus 1 is 50. And the difference we do not know. So what I get S here as 51 by 2, 2A plus 50D. Right? Now we know A here is same in both the cases since the first term is equal, but we do not know anything about the difference. Right? So let's first find out this D in terms of some other variable as A or some other variable so that we can compare S and T. Right? So first thing, what I'll do is I'll write those S and T which we got at the top, 51 by 2, 2A plus 50D, and T I got it as A 2 raised to 51 minus 1. So you write it as A, or we put the first terms in both the cases as C. So I'll substitute C only. So it becomes easier for us to understand as well. So now I'll erase this. Yeah. So you'll put here C and C. Let's understand this further. One more condition was given to us that said 51st terms in both the cases are equal. So if I use that, 51st term in both the cases are equal, where the first 51st term, this is of arithmetic progression. I can write it as first term plus 51 minus 1 difference, and the first term of geometric progression, that is given by A into R raised to n minus 1. So that is R raised to 51 minus 1. So what I get here is A1 plus 50D, A1 into R is 2, the common ratio, and this is 2 raised to 50. Now what I get here is 50D is A1 into 2 raised to 50 minus A1, or I can write it as A1 common 2 raised to 50 minus 1. So now I'm able to get this 50D in terms of the first term. So I'll replace that first term as C. So it's becoming 2 raised to 50 minus 1. Now further, if I want to solve this, let's see this. So 50D, so S I can write it as 51 by 2, 2C plus 50D. I will replace this with now the idea which we have received, and that is C 2 raised to 50 minus 1. Now let's try to simplify this idea. 51 by 2, 2C plus C into 2 raised to 50 minus C. So that gives me 2C minus C. So it becomes C plus C into 2 raised to 50. Now what I get here is if I put 51 by 2 inside, I'll multiply it with both of them. 51 by 2C plus 51 by 2 C 2 raised to 50. So what happens is I can cancel this 2 here. So the power becomes 49 now. I can also take C common, so I'll take C common. This becomes 51 by 2 plus 51 into 2 raised to 49. Now, if you see S, we have received it as like this. We also know T. Now, C we have in both the cases, but here if I see I have the power of 2 raised to 51. So let's try to form 2 raised to 51 in this S also. So if I write it on the next page, S is C 51 by 2 plus 51 into 2 raised to 50. Now if I want to make this as 2 raised to 51, right? So I need two more 2's here to make it 2 raised to 51. So I can adjust those two more 2's from this value of 51. So I can write this as 51 by 2. 51 I can write it as 47 plus 4 and 2 raised to 40. So I get C 51 by 2, 47 into 2 raised to 49 plus 4 into 2 raised to 40. That gives me C 51 by 2 plus 47 into 2 raised to 49. This 4, if you see, it is nothing but 2 square, right? So 2 square into 2 raised to 49 will make it 2 raised to 51. Now I have got S with me. I have also got T. That's at C 2 raised to 51 minus 1. So if I, let's say, subtract both of them, I can see S is a larger value having more terms compared to T. So let's separate T from S. So if I calculate S minus T, I have C common from all the terms. So I'm taking C common. It is 51 by 2 plus 47 into 2 raised to 49 plus 2 raised to 51 minus 2 raised to 51. And this minus 1 is with a minus sign here also. So minus and minus becomes plus. Right? So this cancels. What are you left with? C 47 into 2 raised to 49 plus 51 by 2 plus 1, that is 51 plus 2, that is 53 by. So I am getting an entirely positive value. I can definitely say S minus T is greater than 0 because that was also given to us that the first term is greater. So it is a positive value. And when it is a positive value, I can definitely say S is greater than T, right? So I have got one condition with me. So either my answers can be A or B. Now let's find out the 101st term in both the cases. So A 101, this is the first term of arithmetic progression. So I can write it as A plus 101 minus 1 and the difference is D. So that becomes A1 we already wrote as C plus 100D. 100D, again I don't know D, but I know D in terms of C, right? So D was 50D was C into 2 raised to 50 minus 1. So I can write 100D as 2 into 50D, or I can also write it as 2 into 2 raised to 50 minus 1 into C. C common, 1 plus 2 raised to 51 minus 2. So if I solve this becomes 2 raised to 51 minus 1. And if I see the 101st term of B, that is a geometric progression. So it is A into R raised to n minus 1. So that is B1 into 2 raised to 101 minus 1. B1 is also same as C because the first terms in both the cases are equal to each other, 2 raised to 100. Now here if I compare both of them, the 101st terms of both of them have C common. Now, if you compare this and 2 raised to 100, this tells you 2 raised to 100 means 2 is multiplied 100 times, which is already greater than 2 multiplied 51 times, right? So I can definitely say 2 raised to 100 is always greater than 2 multiplied 51 times and then also subtracted by 1, right? So this is always greater. So if I multiply C on both sides, what I get here is B of 101. So 101st term of the geometric progression is greater than 101st term of arithmetic progression. This is correct. So if I see the option which matches for both the conditions is B. So I get S is greater than T, and I get the 101st term of geometric progression is greater than 101st term of arithmetic progression. I hope you have understood this method. We'll do the same question by another method also. Okay, let's understand the second method for the same question. Now we know the basics that the terms from B1 to B101 all are in geometric progression with the ratio 2. And if I see the terms from A1 to A101, all are in arithmetic progression with difference, constant difference. We don't know that. It is some random difference D. Right? Now, first thing that was given to me here was that first terms are equal. So let's say that's equal to EC, and 51st terms are also equal. Okay, so let's say it is A51 and B51 are equal. We won't put that as any variable. So the idea which we follow here for the second method is, as you know, arithmetic mean is always greater than geometric mean for the two terms A and B, right? So arithmetic mean for the two terms A and B is given by A plus B by 2. Geometric mean for the two terms A and B is given by square root of A and B. So A plus B by 2 is always greater than root of A to B. Let's see the question and let's try to apply this idea. Now, as I know that A1, B1, both of them are equal to each other. A51, B51, both of them are also equal to each other. Right? So sum of the twos will become equal to each other. But if you understand all the terms between them, that is A2 is arithmetic mean of first and third term. A3 is also the arithmetic mean. A4 is also the arithmetic mean. So likewise, all these arithmetic means, and B2, if you understand, is the geometric mean of B1 and B3. V3 is again the geometric mean. V4 is again the geometric mean. Likewise, till 50th term, all of them are the geometric means. Here also till 50th term, all of them are arithmetic means. And since we already know that arithmetic mean is greater than geometric mean, the second term in the two cases has A2 greater than B2. Simultaneously, A3 becomes greater than B3. A4 becomes greater than B4. A5 becomes greater than B5. Likewise happens till 50th term. And we already know A1 and A2, A1 and B1 were equal. A51 and B51 were also equal. If I take sum of all of this, it is nothing but sum of first 51 terms of arithmetic progression, and that was given to us as a variable S, right? And here if I see sum of all 51 terms of geometric progression are added, and if I see them, that was given to us as T. So if I see, I can judge and tell that S is greater than T, because apart from the two terms, all 49 terms has the arithmetic means greater than the geometric mean, and therefore S becomes greater than T. Further, for the 101st term, let's discuss that. So A1, 51, the first term, 51st term, and 101st term will be in arithmetic, and first term of B, 51st term of B, and 101st term of B will be also in the geometric progression. Now, if you see, it is given to me that 51st term in both the cases is equal. So it is given to me that arithmetic and geometric means which are present for these three terms. So arithmetic mean is this, geometric mean is this. This is equal to each other. When this is equal to each other, I can write this as A1 plus A101 by 2. This is B1 and B101's square root. Right? Now here also if you see A1 and B1 are as same as each other. So if I have both of them equal, we already know the idea that arithmetic mean always has to be greater than geometric mean for two same numbers A and B, right? But if both of them are equal, then out of the two remaining terms, one of them is also equal. I can surely say the other term present in the arithmetic sequence, that is 101st term of arithmetic sequence, will be lesser than 101st term of geometric sequence, because then only we can get arithmetic mean equal to geometric mean. Since arithmetic mean is greater than geometric mean, we are getting them, or we have been given that both of them are equal. So the other term which is present in this case will be lesser than the other term present in the case of geometric progression, right? I hope you have understood how to solve these questions using the concept of arithmetic and geometric mean. So here also I get S is greater than T, and 101st term of geometric progression is greater than 101st term of arithmetic progression. So I'll meet you again tomorrow with the next question. Till then, you can like, share, and subscribe if you are finding this helpful. Thank you.